So it's about time to get started again. I think it's going to be the other contents that what we're going to go for second examination. The coverage is going to be on chapter 7 up to the chapter 10 anyway for the machine design part 1. The content is going to make lectures today is going to be on chapter 7. It's going to be talking about a non-permanent connections anyway, which is going to be emphasis in terms of rivet connections anyway. What does it mean by rivet? Rivet is going to be some kind of like thing that will be fixed up together with some kind of non-permanent things together. That what I said is over here typically uh, non-permanent connectors such as the conventional structural rivets are widely used as in the aircraft, transportation equipment, and other products require considerable joint strength, things like that. So therefore, number one, that what I categorize for the failures of the connection, that what I showed some categorize of the failure, most likely of the rivet connections, most likely failure is going to be happen. Number 1.1 is going to be shear failures of rivet connections look like that. Is going to be some kind of like the shear stress all the way with the rivet connections going to be tear supports look like that. Okay, after we just put together one rivet fixes up together with the two plates, apply the force of F, look like in the picture there. The rivets have been tears apart with the force of F. So therefore, the shear stress of house up there is gonna be like that. And 1.2 is gonna be the tensile failures of the rivet at the main plate. It's gonna be tears apart at the main plate there. So the force of F and sigma is going to be time A. The A is going to be the areas left over anyway. The B minus of D time the T is up there anyway. And then 1.3 is going to be bearing failures of the rivet connectors. This is going to be the bearing failures. It's going to be this thing's going to be the bearing failures of the main plates. That's going to be the things that will be look like projected areas of the connecting holes up there. It's going to be projected areas of T times these look like that. And then another one is going to be this tears apart of the connectors hole look like that. It's going to be tears apart from inside to outside, things like that. So therefore, we're going to provide a space from the rim of M distance from the rim center away. See, this is going to be tears apart from outside to inside, things like that. So therefore, we should provide a distance of M should be greater than 1.75 times D to 2 times of D anyway. And then another way around is going to be tears apart from outside to inside. It's going to be provide space of M from the rim again. So that's why M should be greater than 1.75 to 2 times these again. It's going to be 1.5 again. So number 2 is going to be the types of rivet connectors. We have two types. One is going to be the lap joist as shown in figure 7.6. It's going to show you a single row look like that. We have a single row look like that. See, it's very simple there. We have a pitch. It's going to be the distance apart from one rivet to another. We take a rim distance apart to just avoid the tears apart from outside to inside, things like that. And then again, two rows, one row outside and from inside, things like that. This is for the lap joist. Okay. Another one for the butt joint. Okay. The butt joist means we gonna extra pieces to provide, okay, an extra auxiliary plate to provide, okay, subsequently for uh, the cover plate on the top and on the bottom, the main plate in the sandwich inside, things like that. So therefore, the cover plate should be equal to each other, or sometimes it's not equal to each other. It's going to be another way around, things like that. So another time around is going to be repeating group. It's going to be another way to design for this kind of thing to be the main design. Repeating group is mean, okay? You got to repeat it one by one just from the left to the right, or just flip it over, reversing to the other way around. It's going to be the same thing. So therefore, you're going to design only for the repeating group, and you time it by how many times it repeats each other, things like that. So one thing you should be just remind you just of here, the pit is the spacing between the connector is a given row, and we recommend it to be p just greater than t times of the diameter, and also depend upon specific types of design. The cover plate thickness of T2 for the cover plate, okay, should be greater than half of the main plate thickness, T1 over 2 respectively. This is one of the important things that what you should keep in mind when the design have been take place. Okay, and then this is another thing that what we just put on the design of the things of these particular on the 7.8 and 9 respectively for a particular for a triple row. You may see it very sophisticated when the cover plate is not equal to each other for the top and the bottom cover plate there. See, the top is shorter and the bottom is not equal to each other. So therefore, we have a repeating group there. So therefore, we just design only in the repeating group section there, and then we just time it over how many repeating group that what we have got there. So therefore, this is the thing that what a typical type of the boiler that what we're gonna design on that in a way. Okay. And then this is another quadruple kilos four rows. Okay, a typical the cover plate on the top and the bottom is not equal to each other again. So therefore we can design whatever we can do on that. You may figure out the repeating group is a big one. We have a pitch on each one respectively, P1, P2, P3, and P4 respectively. Things like that. Okay. This is what's sophisticated. And then we're going to talk about the efficiency, okay, the strength of the joint and strength of the solid plate is mean. We just make some kind of reference with the strength of solid plate. Solid plate is mean. We just do with the solid plate then. Solid plate is mean we don't have any holes at all. We just refer to that anyway. So therefore, the table 7.1 show you, okay, a single low lap joist, okay, only 50 to 60%. Double row increase a little bit, triple, it's gonna be a little bit. But for a double row, for a butt joint, it's gonna be better, better, better. So therefore, of course, for the quadruple, it's about close to 100% set away. So in typical thing, we're gonna do for the butt joints a whole lot better anyway. So in the example 7.1, we show you some of the lap joint design, things like that. Okay, you may go over it by yourself for 7.1. Okay, it's very straightforward, things like that. Okay, and 5.2. Okay, I'm sorry, this is going to be 7.2. I'm sorry, change it to be 7.2. Okay, design. This is very good. That was one of my projects. That what I did on the design of the boiler, things like that. That what I did myself. Okay, you just do some of the three-row design, things like that. Okay, I come up with a design look like that. Okay, then what I minimize all the cover plates. Okay, with the butt joint. Okay, design. Okay, you can make go for that. Okay, with my design. Okay, you may go over by yourself. Okay, and then I would like to go for okay for another